Think it's going. All right, any questions? All right, in the absence of questions, let's talk about today's lab. Conveniently, there's a small little hook here. You're gonna, when we go into the other room, and you're gonna find a small little container with a lot of these in it. At this point, the strings are all tied up. Probably we're just gonna need to cut it and start with fresh strings, unless somebody can quickly untangle them. But in essence, this lab is, if I just let go right now, in the absence of friction, this has even with friction, this has far more mass than that does. There's more weight on it as well. And so when I let go, it should just slide down like that. So there's obviously an imbalance of forces in this equilibrium situation. So we can offset that by swinging this around. And it's not falling anymore because the tension up here, well, the stopper up there is not in equilibrium because, well, it's accelerating. The velocity is changing directions. If I swing faster, this will move up. If I swing slower, this will start to fall. What you will be doing is timing how long it takes to go around for particular masses hanging on the end. Now, there are some logistical issues with this. One, you want the stopper to swing as horizontally as possible. And if you watch the video, which I think I have a link posted, you'll notice I do not do that. I have the thing swinging like that because I was doing it by myself. I had to do, in essence, I had to do my own timing, and I was having major coordination issues. So I, in essence, swung it 200 times, and I just could not consistently swing it properly. You, however, will do much better than that. One thing I noticed a couple years ago is that for the people who are swinging it sort of like this, obviously not horizontal, if they started swinging it in the other direction, that often corrected it. And I don't, it's a left-handed, right-handed thing maybe, but whatever it is, if it's not swinging horizontally, try swinging it the other direction. I also recommend you don't want the mass hanging down here to be too much, because the more mass you hang on it, the greater the tension. The greater the tension, the greater the centripetal force. The greater the centripetal force, since the centripetal force is equal to mv squared over r, that speed gets a lot faster. And I've seen it where they had a ½ kilogram hanging on here, and that thing was spinning around like this. And they had to time 20 times. It is not particularly easy to do. Also, the other danger, and this happened first year I was doing this lab here, we didn't have the rubber stoppers yet, and so in a moment of brilliance, I decided to use the small masses, those metal masses in there that had holes in them that we could tie a string to. And so I was sitting at the table in the front of the room, and all of a sudden there's this smack as the string broke, and this piece of metal goes flying across the room and smacks into the board. Fortunately, no one was killed, no one got hit by it, but that was a warning there of probably not my greatest moment of picking those, though it then got rubber stoppers. But also occasionally check the string to see if it's about to break. If the string breaks, well, there's certain things that have to be the same when you repair it or you're starting over. The distance from the middle of the stopper to the top of here needs to stay the same. Regardless of how much is hanging below is not as critical as that distance from the stopper to here needs to stay the same. Now, the way that you do that is you there's this piece of tape down here, and the person who's swinging it basically is keeping an eye on it to make sure that distance from the tape to the bottom stays constant. Now, one thing that some students have done incorrectly is that they swing it so fast that the tape is basically lodged right there at the bottom, and so that distance stays constant, that's for sure. But if the tape is staying in there wedged at the bottom like that, you've introduced another force into it, and the tension here is not the same as the tension here. So they had it wedged there, and that thing, they could spin that as fast as they wanted to, and this wasn't going to fall or go up. It was basically stable because the tape was adding additional force. So we don't want that. And I believe that's an answer to one of the analysis questions. All right, so whatever's hanging down here should not, ideally, doesn't move. Now, as you swing it, this might start swaying a little bit like that, or hopefully that's minimal. I'm doing this like you can see through my arm. So this might be swinging around like that. A little bit's fine. You know, there are, frankly, some of you, if you're like a typical class, some of you have the coordination to do this. Some of you will struggle. Every group has figured it out eventually. But it's possible that you should not be the one swinging this. Also, the more mass you have hanging on here, the faster this will have to swing to keep this in equilibrium. As this is, oh, lost my train of thought. We'll try that one again. All right, so the more mass on here, to keep this in equilibrium, we have to swing this faster to increase the tension in the string. Darn, I lost where I was going again. I thought I'd do a run-up. Nope, it's gone. All right, I'll think of it in the middle of the night, give you a call. Questions up to here? We'll just take another 30 seconds to remember what I was going to say. It would have been absolutely brilliant, no doubt. All of your lives would have been changed. Yeah. Yeah, it's gone forever. All right, I say let's mosey over to the other room and get swinging.